We tend to treat the 24-hour day like a rigid law of the universe. In reality, human biology operates on an internal rhythm of about 24 hours and 11 minutes. Dividing the Earth's continuous spin into exactly 24 neat little boxes was an entirely human choice. Looking at the Giza Plateau in ancient Egypt, you are seeing the birthplace of our daily schedule. Living under a bright desert sun, the Egyptians created the first clock by splitting the daylight into 10 main parts, plus 2 extra hours for morning twilight and evening dusk. They liked the symmetry of exactly 12 hours of light. This diagram shows exactly why they chose the number 12. If you look at your hand and use your thumb to tap the individual bone segments of your other 4 fingers, you will find exactly 12 segments. While one hand counted out those 12 distinct segments, a person could use their free hand to keep a tally of how many groups of 12 they had completed. Every person walked around with this biological calculator built right into their joints. By combining 12 hours of sunlight with 12 hours tracked by the stars at night, the ancient world built our 24-hour day on the specific anatomical limits of the human hand. To track those 12 hours outside, the Egyptians placed a simple stick, a gnomon, in the dirt. By carving markers into the stone around it, they could watch the shadow shrink and grow to measure the passing day. But as this dial shows, early timekeeping had a built-in stretch. Because daylight shifts with the seasons, the 12 daytime hours were flexible. A single summer hour was physically much longer than a winter hour. For an agricultural society, this made perfect sense. Farmers needed to work while the sun was up, so their daily schedule naturally expanded and contracted with the available light. This seasonal stretching worked perfectly for planting wheat. But relying on a constantly fluctuating standard made it nearly impossible to coordinate precise mathematics, long-distance trade, or detailed scientific observation. This illustration brings us to the ancient world's premier data center, the Great Library of Alexandria. Here, Greek scholars began synthesizing Egyptian sky observation with Babylonian math. Around 150 BC, an astronomer named Hipparchus proposed a massive software update for how we measure the day. He argued for equinoctial hours, a system where all 24 hours would be exactly the same length, completely ignoring the seasons. He based this rigid grid on the equinox, the specific time of year when the Earth's tilt allows for a perfectly equal split of daylight and darkness. With these stable, predictable units, later scholars like Ptolemy could calculate the exact movements of the planets and write accurate timetables to predict complex spatial events, like solar eclipses. These standardized hours provided the mathematical precision needed to map the geometry of the entire solar system. In the Middle Ages, engineers replaced the sky with iron gears, using heavy falling weights to enforce the hour. Even with perfectly ticking tower clocks, coordination remained a mess. Every single town still set its clock to 12 o'clock, exactly when the sun was highest in their local sky. As you can see by this plaque, the fix came in 1884. With rapidly expanding train and steamship routes requiring tight schedules, world leaders met and established the prime meridian in Greenwich, England, as the permanent starting line for time. Using that 0-degree mark, they sliced the globe into 24 distinct time zones, with each zone representing exactly 1 hour of the planet's rotation. Humanity had officially boxed the sun into a synchronized, industrialized grid that the whole world could follow. Today, we don't rely on gears or swinging pendulums. We use atomic clocks that track the ultra-fast vibrations of cesium atoms to measure a single second with flawless precision. This hyper-precision exposed a glaring flaw in our math. The Earth is actually slowing down. As the moon's gravity pulls on our oceans, the friction from the tides acts like a brake on the planet's rotation. Watch this diagram. The Earth doesn't just spin, it precesses. It wobbles on its axis like a slow top, altering our orientation to the stars over a 26,000-year cycle. In this split view, atomic clocks count perfectly, while the planet slowly falls behind schedule. To keep our digital grid aligned with reality, scientists periodically deploy a leap second. They literally add 1 extra second to the world's atomic clocks, giving the physical Earth a moment to catch up. No matter how exact our engineering gets, our pristine math is still a subordinate partner to the messy physical reality of the solar system. We started measuring the day using the bones in our hands, refined the math in Greek libraries, and eventually locked it down using the vibration of atoms. As we look toward building colonies on Mars, we face a new problem. A Martian day, or a sol, is about 24 hours and 39 minutes long. We will have to break down our system and invent a new clock from scratch. Every time you check your phone or glance at your wrist, you are looking at the result of 4,000 years of human compromise. The 24-hour day is an invisible web we built, our best attempt to sync our biological bodies with the magnificent, wobbly mechanics of the cosmos.